If you have information about a line, can you actually find its equation? Now, this presumes that you're going to assume that the rate of change, how quickly one variable is changing, stays the same. That's a key feature about a line. No matter where you are, the y-coordinate is changing at the same pace. Okay, so making that assumption, one thing to realize is slope is a rate of change. It's how quickly things change. So for this example, you're renting a car. You write out, the rental agency prints out a contract, you sign it, you agree, you're going to pay $40. You're also going to pay $4 for every gallon of gas you do not refill. So they say, instead of half a tank, refill it to half a tank. If you return it less than half a tank, we're going to tack on an additional $4 for every gallon you did not put into the car. Okay. So how much have you used up but did not replace? Okay. So now the $40 is a base price. So that's like a y-intercept. That's like if you have 0 gallons of gas you did not refill, then it's going to cost you 40. So that's where you start. So you start at 40, all right? And then the $4 per gallon is a rate of change. Your cost increases by $4 every time for every 1 gallon of gas you forget to put back into the tank. And so we're going to write this kind of like a change of y over change of x. The cost will change by 4, so that goes in the numerator, by every one that the tank, 1 gallon of gas that you did not refill. Okay, so if you do not refill 2, then it goes up. Then the cost goes up by 8. If you do not refill 1.5, it comes out to be 6. Okay, and then often we'll just drop the units. So we'll drop the dollar sign, we'll drop the gallon, and we'll just say 4 over 1 is 4. Okay, and then back to a previous video, y is mx plus b. M means slope, and that's a 4. B is the y-intercept, that's a 40. Okay, and that's it. That's your equation. Now, you can also be given other information. What if you're given the y-intercept from another point? Here, you are given, in this example, you were given both the y-intercept, the 40, and you were given the slope. What if you're given 2 points, and one of them is the y-intercept? Well, you're still going to say m is the change in y over change in x. And one thing to keep in mind to spot some of your own mistakes is that if you have an increasing line, it will have a positive slope. If you have a decreasing line, it will have a negative slope. Okay, so here's an example. In 2008, which we'll consider to be time 0, the population of Ohio was 11.53 million people, and in 2018, it was 11.69 million people. So population went up by just a little bit. So the slope is the change in the population. So 11.69 minus 11.53 comes out to be 0.16. That's the change in population over the change in time, 10 years. So I got the 0.16 divided by 10 comes out to be 0.016. That's my slope. And since I'm considering 2008 to be times 0, right here's my beginning population. So that's my y-intercept. So I've got population is the slope multiplied by my other variable, t. That's not a plus sign, that's a t, plus my y-intercept, my beginning amount, my 11.53. Okay. What if I have 2 points and neither one of them is the y-intercept? So you use the same formula to figure out the slope, and then we've got this thing. Here, y1 does not represent y times 1. It actually means the y-coordinate of one of your points. And x1 means the x-coordinate of the other point. Or, excuse me, x-coordinate of the same point. Okay, so here's an example. What line connects these 2 points? So you figure out the slope. Difference between y, 7 minus 4 is a 3. You figure out the difference in x's. 5 minus 2 also comes out to be 3. And so you got 3 in the numerator, you got 3 in the denominator. 3 divided by 3 simplifies to be 1. Okay, so that's your slope. Now you're going to start plugging things in. Y stays y, and x stays x. Well, y1 gets replaced by the y coordinate, so 4. And x1 gets replaced by the x coordinate, 2. And the m gets replaced by 1. And then you distribute. Well, 1 times anything is that thing. So 1 times x is x. 1 times negative 2 is negative 2. Then, after distributing, you're going to take this number, you're going to move it to the other side. So I added 4 to both sides. I had negative 2 plus 4 is a positive 2. Okay, now with this, by the way, I could have used the other point. So instead of the 0.24, which I used to fill this in, I could have used the 5, 7. And right here, it would look different. But once I solve for y, it would still be y is x plus 2. That is one of the reasons why slope-intercept form solved for y, why that is so popular among math teachers, is because if you've got different numbers here, it's a different line. If I had 3x plus 2, it's a different line. If I had x plus 6, it's a different line. But with the point slope form, this one, different numbers. If this is a 7, and if that's a 5, it actually is the very same line. Even though it doesn't look like it, it turns out to be the same line. Okay, so it's kind of hard to tell what lines are different in this format, but it's easy to tell here. Enough of that. This is how you go about finding the equation, and it doesn't matter which point you use, just as long as you don't mix and match. So you can't take the x coordinate here, say that's a 2, and the y coordinate there and put a 7 here. So you can put a 7 here and a 2 there. Those are coming from 2 different points. That's not good. All right, that's it for finding the equation.